Hello everyone and welcome to Java Basics. Today we will up the ante. We will discuss Spring Boot, which lets us build web applications. We will discuss web services and we will build a Wordle version that works on the web, which we will do next time. But first, today's code is in this URL. It is in the video description, so you don't need to copy it. Spring has a lot of history and I won't get into it here. There's just too much to cover, and the underlying principles are too complex. Instead, I'll just teach them by example. But I will discuss the concept of framework. We imported Moshi last time around. How is a framework different from a library like Moshi? A framework is more than a library. It's an all-encompassing set of libraries and that expects you to write code to fit the framework. It's much larger. Server applications typically include a lot of dependencies and complexities. As a result, we typically scaffold them. That means we create them using a tool that creates the initial project for us as a starting point. In this case, we will use the string initializer. Notice this isn't a spelling mistake. That's how they write it. You can find the string initializer here. It looks very much like a standard new project wizard. This is the Spring Initializer main page. It condenses a lot of functionality into a single page. First, I'll change the default project from Gradle to Maven. I'd love to demonstrate Gradle, but at this point it's a bit flaky when compared to Maven. This might change in the future. Next, I'll name the group and artifact like any other Maven project. Notice I use the same package convention as before, and as I type the group ID, the package name below updates as well. Now it's time to add dependencies like we do with every Maven project. The initializer includes some common dependencies as part of its install. We can open the dependency dialog in the Add Dependencies button and select from the list. There's a search bar on top where we can type in the name of the dependencies as we add them. I'll add a few which we won't use at the moment, but will use later on. The first dependency I'll add is the Developer Tools extension to Spring Boot that provides some ease of use tools. When you add a dependency, it closes the dialog unless you use the Command or Control button while clicking on the dependency. Notice the dependency was added behind me here. You don't really see it, but we'll see it. We'll see all the dependencies once we close this dialog. Next, we add Lombok, which is a library that makes it simpler to manage some objects. We add Spring Web, which will let us implement a website. When we proceed, to add Spring Web Services, which provides a way to invoke a method over the internet. This is the basis for RESTful web services that we will discuss soon enough. FineLeaf is a web templating engine that lets us build simple HTML pages with functionality within them. This lets us customize the HTML pages we show to the users. Spring Data will provide a new way for us to save data in the database, which is how real companies save data, not just in files. Databases are powerful tools that we can use to organize and store data at a very large scale. For this to work, we need a database. There are many great databases, but I'll pick H2, not because it's good, because it's simple and doesn't require any additional installs. In a real-world scenario, we will probably need more than that. We can close the dialog by clicking outside here, and here we can look at the full list of dependencies. By clicking the Explore button, we can inspect the code that will be generated. We can click, close, or press Escape to close this, and click the Generate button to download a zip file with a full project. This will go into your Downloads folder. I moved the zip file to my Projects folder. Next, unzip the file, and we got. we can rename the folder to a more reasonable name. Next, we need to go back to IntelliJ. In IntelliJ, we can select the file menu and then click on the open option and open this new folder. We select the Wordle string directory we just named and click the open button in the dialog. As usual, I select to open the project in a new window, but you can just replace the current project. This loads the project and that might take a while. Unlike a regular project, we have a lot of dependencies here, so Maven or Gradle might spend some time downloading dependencies and update you in the bottom of the screen here. This is okay. My connection is fast and I already have many of the dependencies cached, so this moves quickly. Typically, we would work with the regular Maven lifecycle targets when building an application, package, test, etc. But for Spring Boot applications, we need to use the Maven plugins that provide their own targets. As you recall, Spring Framework is really complex. So these plugins hide a lot of that complexity behind simple Spring Run target. All we need to do to run this project is right-click and select Spring Boot Run, :run. Then in the right-click option, run the Maven target. Once we click that, you will see a lot of printout indicating the stages of launching the application. This culminates in the printout started Wordle application at the end, which means Spring Boot finished launching. Notice that if we have configuration errors, they will appear in this console as well. Going to the browser, we will navigate to http://localhost 8080. This will open the following error page, which doesn't seem like much, but it means the web server is working correctly. By default, Spring Boot uses the 8080 port for HTTP. The reasons behind this are both technical and historical, and I won't get into that here. When we navigate to this page, we get an error message. If we read it, we see that this is our Spring Boot application and it works, but it doesn't have anything to show for the root page. So let's give it something to show. Going back to the IDE, we expand the src directory and then the main directory where the project source code resides. But instead of the source directory, we have another directory here, resources, and under it, we have the static directory. Here we can place files that we found on the that will be found on the web server. We can put images here or HTML files. We right-click the static directory and select New HTML file from that context menu. We type in the name index. Notice I don't need to include the .html extension as this is the default. The index file is a special case and will appear in the root of the project when nothing else is found. This creates a simple HTML file. HTML is what we see when we navigate the web. I'm guessing most of you are familiar with it to one degree or another. Notice it's pretty similar to the POM XML file we saw previously. This is because both of them have similar ancestry. We just type Hello World in the title area and also Hello World in the body. So we will see something in the browser and know that it worked. I stop the project and run it again, like before, though through the Spring Boot Run context menu. Going back to the browser, I can now click reload and see the Hello World message from the HTML file. We just created a simple web application. This was a lot, but we're only just starting. Next time around, we'll start integrating the code we wrote for Wordle with Spring Boot. We will continue where we left off. If you have any questions, please use the comment section. Thank you.